Howdy folks, Bill Yaley in the Mad Scientist Lab again, and this one goes out to my Uncle David who challenged me. The number one question that you guys have to have is, I have 3 multimeters and which multimeter should I use? We're here to answer that. Alright, let's go to the bench and I'll show you what I'm talking about. Alright, so this whole conversation picked off when I set out to repair this old multimeter. It's a Radioshack version. I've had it for at least 20 to 30 years. I got this thing back in college, so I was about 20 years old, and now I'm over 50, so goodness, over 30 years old. But it started acting up, and the plastic has dried out and started cracking in half. You can see a little crack there, and there's another one right there by the hinge. Of course, the lid is long gone. No telling where that is. But anyway, I opened it up and cleaned out the contacts for this rotating knob. And this thing was flat, you know, and I always had troubles getting a hold of it and turning it. But when the thing just sort of disintegrated in my hands, I super glued as much of it that I could find back together. And then I thought, well, shoot, I'll just get some of this JB Weld, like I like to use on a lot of things. But yeah, just sort of smushed that into there and got this cheap gray knob with a little indicator right there. And lo and behold, after cleaning the contacts in there, all of the settings and stuff work, especially the continuity test. How do you guys do this with one hand? Alright, so continuity. If I touch the probes, hopefully you can hear that. Anyway, so then the question was like, hey, since you repaired that thing, how are you sure it's not drifting off value and it's no longer accurate anymore? So I thought, well, I've got these other meters here. So there's one I repaired from Radioshack, 30 plus years old. This one, hyper tough. This is one I picked up at Walmart, and I thought, you know, I've been using this old beat up one for so long, I deserve to have a new meter. And this one, I'll show you, but this one truly sucks. So then I was at a flea market a couple of weekends ago, and they had this Simpson 260. It's this nice heavy and bulky analog meter. I did have to clean up the electrical contacts. They're there in the back. You can see how that's kind of turned green there. Anyway, this uses a D cell, and there's also a 9-volt transistor battery in here as well. So, you know, and this thing, once the battery terminals were cleaned up and such, and I also had to buy some new probes. I can do a quick test, touch probe to probe, and you can see the meter move over to 0 because that's a short circuit. So what does all that mean? Alright, so the question came from my Uncle David, who used to, he's retired now, but he used to work for the Bureau of Weights and Measures for the state of Colorado, and he's also a physicist like myself. So when he asked, well, if you've got 3 meters, which one do you use as standard and why? And I thought, well, okay, I guess I need to do a few things. But I'm going to get the camera in a better position before I do that. Alright, so on the bench we have the ancient and repaired Radioshack with its custom knob, the Walmart bright yellow version, and the ancient Simpson 260 multimeter. Alright, so test number 1. I should be able to put this on a resistance test. And okay, it's overload. It's saying overload right now, just because the probes aren't touching anything. So clear this out. Hopefully you can still read that just fine. Whoa. All right, so if I touch these probes together, I'll get a short circuit, and it should measure 0. All right, so right there it says 0.0, which is what I would expect. All right, so there's that one, first test. Now, getting over to the Walmart-y one. Okay, I've got it on the 200 ohm setting because I'm going to test it here in a little bit with something very small. If I touch the probes together on this, I would expect it to register 0 again, right? So I do this. 0.4, 0.6, 0.3. It's just all over the map. Alright, so 0.3, 0.4, 0.5. Alright, it seems to be settling in at about 0.4. And as I talk, the resistance changes. Okay, the point is, it's not 0, and it should be. I mean, there's no smaller resistance I could get than this, and it's still measuring 0.3, 0.4, 0.2 now. All right. Now then, let's go over to the big dog, the Simpson 260. All right. Got to do a couple of things. For one, that's the off position. Put it on plus DC voltage. Set the dial for R times 1. So now this measures infinite resistance over here and down to 0 on that end. So putting the probes together, I would expect it to read 0. Now that's going a little bit below the 0 mark, so I can turn this knob to adjust it so that it does show up at 0. Okay, so there it goes to infinity again, and back to 0. Infinite, 0. Okay, so out of the 3 meters, this one can be adjusted to 0. The Radioshack one automatically adjusts to 0. Okay, and this one just reads off, and it's also very inconsistent. All right, now then, I have over here somewhere, before I have lost it and lost my mind, I have this wire wound power resistor, which according to the label on the back, it's a 20 watt, but an 8 ohm resistor. So, and these tend to be fairly accurate because the resistance of the wire that's inside of here, they know how much of a resistance it has per inch or per centimeter, so they can measure out a pretty exact amount of a length of wire, coil it up, and put it in here, and you get this wonderful, fairly accurate resistor. So this is going to be my test subject, if you will. So let's take a look at the Radioshack meter here. It's still on. Put my test subject there. All right, so once again, touching the probes, it reads 0. Okay. Now if I go to the 2 leads on this, I'm trying to avoid touching with my fingers because I don't want to measure the resistance of my fingers alongside of it. All right, so 8 ohms, actually 8.0. All right, cool. So test 2 shows, yes, it's 0 at a short circuit, and it measures an 8 ohm resistor at 8 ohms. Okay, so it's consistent and it's correct. Point 0.6, 0.5, 0.4. Alright. Same thing as before. Testing the 8 ohm, and we get 8.3, 8.4, 8.2. 0.4 on the short circuit, and 8.2, 3, and 4 measuring the power resistor. So, for one, it's incorrect. So, I don't know where 0 is on this guy. And then if I measure this guy, he winds up being, it's pretty much the same behavior if I do a short circuit. 3, 5, 4, 3. And I go to this guy, 4, 3, 2. So anyway, this one is consistent in that it always reads high, but it's incorrect because everything is off by whatever this 0 amount is. You know, when I was doing this test yesterday, this thing was off by like 2.3 ohms consistently. So, consistent but incorrect. All right, now the big dog. Once again, let's see, test for 0. All right, 0, short circuit. Now, I'm going to test this guy, and that looks to be about 7.5. So 7.5 ohms, a little bit off. Short circuit, 0, and 7.5. All right, so this one, right on one side and incorrect on the other. So this one's not correct. It's not even consistent because yesterday it was doing some crazy things. And these batteries are fresh. I've cleaned this thing out, so it, see, that's not even pointing 0 anymore. So Lord knows, maybe there's a spring, somebody had suggested that the spring will toughen up and change over time so the needle doesn't deflect as much as it should. All right, so what did we learn? We've got an old meter that's consistent and it's correct, as best as I can tell. And then we've got another one that's incorrect, but it's consistent, sort of. It takes it a while to settle in. And then we have this guy, which is not very consistent, not very correct, but it looks cool. So, my decision is this is the go-to meter. Yeah, it's rough, it's been repaired, it's held together with Scotch tape, super glue, and epoxy, but it works. Consistent and correct. It even has some, see some pitting and stuff on the probe there because one time it arced. I was doing a voltage test. Let's see if this high power line is working. Zot. And it survived that. So anyway, so there you have it. Shout out to my Uncle David. Thank you for posing the question. And this is Bill in the Mad Scientist Lab signing off. Be safe, guys.